Hi, everyone, and welcome to Module 5. Last week we've talked about GMOs, and the week before that, pesticides. And I've really been enjoying the discussion board and all that you have been contributing to discussion of these topics. I think we have a really nice diversity of students in this class. So I just want you to know that I really appreciate everyone's willingness to be open-minded and put their thoughts and educated opinions out there. So last week we talked about GMOs, and I thought that the debate was incredibly interesting. I really liked how one of the topics that came up was that maybe the issue isn't the genetic engineering technology itself, but maybe it's more the broader context under which this technology is utilized or placed. And I came across another interesting article about GMOs. This one was from a food systems researcher at UC Berkeley. And one of the things she says is safety in some has been narrowly defined as human nutritional health, excluding many important safety dimensions and ignoring impacts on the larger agricultural, social, and ecological systems. So when we think about this broader approach when we're interpreting scientific evidence, it really fits in with the goals of this class in environmental nutrition, specifically, in that we're trying to go beyond the specific food that we see in front of us and think about it in the larger global context. So that being said, it's very important to be thinking about balance and be open-minded to both approaches. And I think when we're talking about food animals this week, that's particularly important. The consumption and production methods of food animals is, like the other topics we've discussed, extremely controversial, and I think it can really really appeal to people's core belief system. So I think the book does a really good job in the reading that you were assigned for today, of outlining the fact that evolutionarily humans are omnivores, and it's really may not be realistic to expect a complete shift away from meat products in the world. So then we need to think, okay, how can we include meat in the most environmentally, socially, and healthfully responsible ways? And that's what we're going to talk about today. Okay, so I'm not going to talk today about the environmental impact of meat production. I think you've had exposure to that in this class already, and there's some about that in your readings, especially the one from the book. So I'm not going to belabor that point, but instead I want to talk about the specific animal food production methods associated with environmental impact. And this really came from the request, I think, of many of you that expressed interest in understanding how different methods of raising livestock could impact the environment and human health. So we'll talk about that. And then the other learning objective is to explain what antibiotic resistance is and why it occurs, and then also describe how antibiotic use in animal food production may impact human health. Okay, so when we talk about the different production methods, I think it's really important to understand that there is just such a wide diversity of meat production methods within these categories. But I do want to touch base on the specific definitions of these categories. So here we have the conventional system of beef production, in that pre-weaning, the cows and calves primarily subsist on forages, and then supplements are provided during times of nutrient deficiency. And then post-weaning, the calves may continue to graze, and at that point, they may be moved from their original place of birth to a feed yard or feedlot. And then the real stage that defines the conventional system, I think, is this finishing in which cattle are fed a grain-based diet until they reach their desired body size, or sorry, the farmer's desired body size for them, and then they're harvested. So then we have natural, which I believe is almost the same method, but with a few changes. So let's see here. So some of these things are the same as the conventional. However, the natural involves post-harvest handling and refers to a product with no artificial ingredients or added colors. So you might notice that sometimes in the grocery stores that meats are very, very red because a color is added to make them appear fresher. So in a natural product, you wouldn't have that, for example. And then we have the grass-fed beef. So supplementation is limited to times of stress. And same thing for post-weaning. And then the real difference, again, is that the cattle are able to graze until they get to their desired body size when they're harvested. So they aren't finished on these grains. And I believe, as you would assume for grass-fed, there's a kind of a specified quantity of land that must be available to the animal. And then we have organic, which basically the difference is that all feed and supplements have to be organically produced. So one thing that one reading that you had was the reading about the CAFOs, the confined animal feeding operations. And I thought that was a really interesting article. It was from the National Association of Local Boards of Health, but I found it on the US or the NIH website. And so that's kind of a description of what a CAFO is, and that would be referring to this last stage in the conventional production. So that's where that all fits into this. Okay, so again, there's been specific requests to understand how producing meat in maybe what we would think of as a more environmentally friendly way may impact environmental and health outcomes. So again, there is a considerable diversity in the management and production of methods. And as with all of the other topics we've investigated or examined, the environmental impact according to the production method of meat production is very controversial. And the reason is because it's looked at from different perspectives, taking different scenarios into account and taking different criteria into account. So again, I did look into this, and I was considering have you read the articles and decided against it because they're very technical, but I do have some citations down here, so please feel free to pursue these more if you're interested. And with any of the articles that you see, if you need more information to find the article, or if you can't find it and need me to send it, I can do that. So all of that to say, there really wasn't that much information on this topic, in my opinion. And nearly all of the information that was available on this topic were from the same author, this Capper. And so she was an author on this article too, and then she also wrote this review. And the papers were great, very detailed, and we also have to consider that this is really one person's kind of perspective. So all of that to say, it seemed that her conclusion was that, and bear with me until we get to the next slide and I kind of explain a little bit more, but her conclusion was that conventional beef production may have a lower carbon footprint because the animals grow to a greater size in a shorter amount of time, and they're contained to a smaller piece of land. So her conclusion was that because of these factors, conventional beef production would have a lower carbon footprint because you need fewer animals for the same amount of meat they take less land and water in fossil fuels because they are kind of contained in this small amount. Um, and it's very efficient, I guess is their argument, of fossil fuels to produce a set quantity of beef. So, what how the study was done and how all of these studies are done that I saw is that they're assessed by a model, by this kind of life cycle analysis, they call it, where they take vital statistics of all different stages of the meat production system, and they use this information to build this carbon footprint of this animal over its lifespan and see, okay, over its lifespan it uses this much and it produces this amount of meat, so which is more efficient. So this is all based on modeling. Because as you could imagine too, it would be really difficult to measure this kind of a thing. So we do have another article here that was looking at dairy, and they said that grass-fed dairy would have a similar carbon footprint to conventional, but when they considered the impact of carbon sequestration in the grass-fed model, then the grass-fed dairy actually had a lower environmental impact. And in this previous study, the carbon sequestration factor was very important as well and made a really big difference when it came to comparing the conventional to the grass-fed. Now, I'd also like to say that I would encourage you to read this article if you're interested in this topic. Another thing is that, again, all of these are kind of theoretical figures. And so when they would play with them one way, it would come out one way. When they would play with them a different way, it'd come out a different way. So anyway, all of that to say, in this third reference, which is a review of the topic, the authors conclude that a considerable knowledge gap exists as to the contribution made by on-farm practices and herd dynamics upon environmental impact. Okay, so let's see. That's all I had to say on this slide. Now, all of that to say, as they built this model, I think it's the same issue that we've kind of encountered in many of the topics that we've examined, which is, are we considering a broad enough system in order to understand all of the ramifications of our production methods? So for instance, how can we quantify animal welfare? So many people have expressed concern, many animal rights groups have expressed concern over the living conditions in many of these confined feeding operations. So maybe it wouldn't be important to an individual, but maybe it would be, and how can we really account for the impact of that? Also, are we taking into factor external costs? And again, in that article about the CAFOs, and then I think in your other readings as well, they discuss the environmental impact beyond the carbon footprint of it. So, for instance, while these analysis that I talked about did discuss the fossil fuel and water requirements for the different feeding operations, they really don't consider, and they do consider carbon sequestration, but that's really not all of what the benefits of grass-fed beef on soil are, and then don't consider biodiversity. And in addition, these analyses really can't account for the external costs of pollution from animal waste and fertilizers. So maybe those wouldn't be costs that need to be addressed now, but may need to be addressed in the future. And then also the social costs, economic costs, and healthcare costs. And so these are, again, discussed in that CAFO article as well. And we're going to talk about a specific healthcare cost that is of concern to many people that believe it may be associated with these animal production methods. So I do have a YouTube video here, which is another TED Talk. And this TED Talk is from Joel Salatin. I'm going to click on it to get it loaded while I continue talking. So this gentleman is a farmer. Again, I apologize for that. Hold on one second. So this gentleman is a farmer somewhere in the east, I believe, but he is kind of the guru of grass-fed meat production, and he lectures on it regularly. So I thought this would be a really good opportunity to look at his take on the impact of grass-fed beef on the environment. And what's this was actually just done January 14th of this year, so it's a really recent video. So let's go ahead and watch that.
Sunbeams are the essence of poetry, dreams, fantasy, fairy tales, sunbeams. And yet, as esoteric and mystical as sunbeams are, they are the energy driver of the planet in a very visceral, physical, scientific, empirical sense. But if I asked you to go out and grab me some sunbeams, we know they're valuable, right? Well, grab me some. Could you bring them in here? Let's talk about sunbeams. Well, you know, children, they'll take you up on this. They'll dance around a little while and try to grab them, but they can't. The fact is that something as esoteric and mystical as sunbeams is captured by nature's photovoltaic array called photosynthesis in plants, through the chlorophyll of plants, and specifically grass. So, the problem is that most of us in our modern culture are quite disconnected from grass. When I say grass, you know, people immediately think of lawns, golf courses, maybe a soccer field. But you're not thinking about the kind of grass that the Knights of the Golden Horseshoe found in the early 1700s when Governor Spotswood, the colonial governor of Virginia, sent his friends, dubbed the Knights of the Golden Horseshoe, I mean, they were British after all, sent them across the Blue Ridge. The British had bumped up here against the Blue Ridge. What was over Afton Mountain? What was over there? So he sent them over to discover what was there. And what they found, they wrote back, and they spent a couple of weeks, and they said, everywhere we rode in the Shenandoah Valley, we could take the grass and tie it in a knot above the horse's saddle. It was a magnificent silvopasture of elk, deer, passenger pigeons, prairie chickens, pheasant, turkey, and bison, up to herds of 3 to 4 million. Captain Jim Bridger got behind a herd out in the Black Hills of Dakotas when he was sent out to explore it, behind 7 million bison. Now, that's always intrigued me. You know, can you, Lieutenant, could you come up here a minute, please? Sharpen your quill. Start counting. 1, 2, you got that? 2, 3, yeah. I have no idea, all right? But the legacy of these migratory herds that were moved by both natural and Native American lit fires as a landscape choreography, and these migratory patterns where they moved thousands of miles created the soils that we are currently mining today in the Midwest and that we already mined in Virginia, up to 3 feet of topsoil washed off of Virginia during the European colonialization of the state and up until today, and is still washing off today, because we have turned this beautiful perennial-based system into an annually based tillage system, which is highly erosive. In the Shenandoah Valley, where I live, arguably 3 to 5 feet of topsoil have washed out and created the turbidity in today's Chesapeake Bay. But how does nature actually work? How nature works is sunbeams come down, it's captured by photosynthesis and converted into biomass, into vegetable material. And if we look at the different kinds of plants, trees, bushes, and grass, intuitively we think, well, what's the most efficacious plant to collect these sunbeams and turn them into and sequester the carbon? Well, your mind tends to go to trees because you can see, oh, wow, look at all that biomass. But in actuality, trees are the least efficient. Brush is more efficient, bushes and brush and things like that. And then the pinnacle is grass. The fact is that when you look at a forest, you're seeing 50 to 80, maybe 100 years of stored carbon all standing visible. You're not seeing 80 years of grass visible at one time. Now, the grass goes through a growth cycle, just like us, just like all living things. It goes through a growth cycle. It starts slow, and then it accelerates, and then it goes into senescence. So the 3 stages of grass I call diaper stage. So right here in this pot, I have freshly eaten diaper stage. This is infant grass. It's just been grazed and it's coming back. Here I have teenage grass. Okay, juvenile fast growth grass. Remember when you could eat a half a gallon of ice cream and it didn't go on your hips? This is juvenile grass. And then we come into, more juvenile, but you see it starting to brown down, and eventually it goes to what I call nursing home grass. Okay? Senescence, the end. The role of the herbivore in nature, if you've ever thought about it, and the reason I'm concentrating on this is because herbivores have gotten a bad rap in recent days. Cows, climate change, and all that stuff. You see, the data points to study the effect of cows on the environment are all coming from a position that does not respect and honor the herbivore in its classic role. The role of the herbivore, and the reason the planet is so full of herbivores, think about Africa, think about South America, the alpacas, think about Indochina, yaks. I mean, they're all over the place. Reindeer, caribou. There's a lot of herbivores, groundhogs, prairie, everything. Is because without them, this biomass would simply turn into senescent material and just volatilize and die and quit growing. So the role of the herbivore in nature is to take this as it approaches senescence, prune it back, just like a viticulturalist would prune a vineyard or an orchardist would prune an apple tree. Does anyone think ill of an orchardist? Why are you pruning your apple tree? No. We think that's good. We think that's good stewardship. And that's exactly what the herbivores did. So they pruned this back to restart this rapid biomass production. Without them, it stops. The whole program stops. Now the problem is, how do we duplicate this if we don't have migratory patterns? If we don't have 4 million buffalo in a herd? If we don't have 10 million wolves chasing them? If we don't have fire? If we don't have the magnificent, amazing choreography of nature, how do we duplicate this amazing principle that hydrated, built soil, fed all the mycorrhizae and the actinomycetes and built the soils that we're still mining today? How do we duplicate that if we have a system of private land ownership and all that? Well, we do it with high-tech electric fencing. Space-age, microchipped electric fencing. It's almost invisible to the eye, and yet we can encircle a herd of 1,000 cows with almost an invisible wire that you would never see. I mean, visitors to our farm have to watch the wire. They walk into it, and so, it's practically invisible. But because it's such a strong psychological barrier, the cows learn, and they can see way better than us. In fact, they can see all the way around their heads. So, well, except for 30 degrees on their back end. So they can see this, they know it's there, and it allows us to duplicate this mobbed movement that they would have had in eons before we had private land. And so we call this mob stalking, herbivorous solar conversion, lignified carbon sequestration. And so as the biomass gets to this point, we prune it back with the herbivore, and then it begins to grow. And as the leaf area begins to get more and more chlorophyll, the growth accelerates and accelerates, so that from here to here is, let's just say for sake of discussion, from here to here, this time period is 20 days. From here to here, the time period is only 10 days. All right? So it's accelerating, and then it slows off. So what we're doing is using the herbivore, in this case a cow, it could be a sheep or a goat or whatever, but in this case a cow. We're using the animal in its historic role, using high-tech electric fencing in order to leverage and stimulate the biomass production. The bottom line is that in Augusta County, where I live, which is over the mountain, in Augusta County, the average pasture, the biomass production, if you dry it down and you weigh it, the biomass production on the average acre of grass in Augusta County is 2,500 pounds per year. On our farm, we've been there almost 60 years. We've never planted a seed. We've never bought a bag of chemical fertilizer. And on our farm, we average well over 10,000 pounds per acre. You know, we're all familiar with the tension between ecology and economy, and that there's a battle, and we can't be environmentally sensitive unless we sacrifice the economy, and we can't be economically viable unless we sacrifice the environment. And I'm here to present to you the notion, as a fact, that we can actually have both. But what we have to do is manage things completely differently. You see, the data points that impugn the lowly cow as the destroyer of the planet have the wrong object to have a problem with. The problem is not the herbivore. The herbivore is doing what she's always done. She's, a four-wheel drive portable sauerkraut vat, turning carbohydrate, fermenting it into, meat and milk, nutrient-dense food. She's doing exactly what she was supposed to do. But she's not being managed the way the wild herds and the migratory patterns were managed, where they moved and they vacated areas long enough for the forage to go through this magnificent 50, 60, 70-day physiological expression cycle, and then be pruned back and harvested at the appropriate time. In fact, what happens is that on most pastures, even at this, the grass never even can grow to this point. It's kept very, very short. So it's pruned 20 times in a season, and you add up all those little couple hundred pounds a time, and it comes out to about 2,500 pounds per year. Instead, we let the forage come way up here to full physiological expression. By denying access, we move the cows every day to a new spot, letting everything else rest and go through this rapid accumulation cycle. And what it means is that we triple, quadruple, and even quintuple the amount of forage that can be produced on a certain area. Now, that cow is dropping 50 pounds of goodies out her back end every day. So just think about what happens when you change it from 4,000 pounds of manure and urine per acre to 20,000 pounds of manure and urine per acre. Suddenly, you have soil building capacity. So here we are not only harvesting way more, but we're sequestering way more carbon. We're using the animal in its historic role. We're honoring and respecting the cowness of the cow. When you feed the herbivore foreign things like grain, and you lock them up in a feedlot, and you do all the kinds of desecrating things, I mean the U.S. duh, I call it the U.S. duh, for 30 years, laughed at us for doing this. They said, grind up dead cows, feed them back to cows, And we were branded Luddites and anti-progressives, anti-science, Go on, get with the program, Salatin, What's this grass stuff? 40 years later, there's this sudden global, oops, maybe we shouldn't ought to done that. And it's beyond me why we still give these sophisticated agents of our culture the freedom to tell us what to eat and how to eat. And so, the what if of this. Just imagine if all of our neighbors did that instead of continuous grazing where they just turn, 50 cows into 100 acres and just leave them all year and the grass can never get above infant, what I call diaper grass. And it just sits there always kind of, in like half of first gear. And there's a lot of analogies we can make here, but the point is that the grass never accelerates. It can't because are they ever going to get out of diapers? Well, it's the same way the forage is. But if we control it so that the animals only access a tiny little spot each day and create a mosaic pattern, guess what? Now we've got moles and voles. We've got bird nesting sites. We've got a continuous mosaic of pollination of blossoms, red clover, white clover, and dandelions that are for pollinators. You've got all sorts of growth going on below the ground because now we have this biology. The soil cools down because it's got all this nice cool mulch that's transpiring, oxygenating, and I'm inhaling the oxygen out of this plant, and it's inhaling my carbon dioxide. I mean, isn't that cool? Okay, and tomorrow it goes through a frog, and then it goes into a goldenrod, and then it comes back in. And it's this wonderful connection. And so, what if UVA would serve this kind of meat instead of the concentration camp meat? What if McDonald's served this? What if Burger King served this? What if you ate this? And what if I ate this as a blessed way to participate in the most healing, amazing, nurturing choreography of nature by respecting the cowness of the cow, using her as an herbivore in her historic role, and participating in the nurturing of the planet. Thank you for letting me share something that's very simple with you. Thank you so much.
Okay, so that was just a really interesting perspective, I think, from someone who practices this every day, and really demonstrates how in the previous slide we talked about carbon sequestration is such a big factor, and maybe that it would be an even bigger factor than researchers understand. So now I want to shift gears and talk about these health costs, or specifically one of the health costs of animal production methods, and that's antibiotic resistance. Now, I didn't anticipate that I'd have two videos in a row, but this one is much shorter. So this is an explanation of what antibiotic resistance is. You can see I'm really a fan of these TED Talks.
What if I told you there were trillions of tiny bacteria all around you? It's true. Microorganisms called bacteria were some of the first life forms to appear on Earth. Though they consist of only a single cell, their total biomass is greater than that of all plants and animals combined. And they live virtually everywhere, on the ground, in the water, on your kitchen table, on your skin, even inside you. Don't reach for the panic button just yet. Although you have 10 times more bacterial cells inside you than your body has human cells, many of these bacteria are harmless or even beneficial, helping digestion and immunity. But there are a few bad apples that can cause harmful infections, from minor inconveniences to deadly epidemics. Fortunately, there are amazing medicines designed to fight bacterial infections. Synthesized from chemicals or occurring naturally in things like mold, these antibiotics kill or neutralize bacteria by interrupting cell wall synthesis or interfering with vital processes like protein synthesis, all while leaving human cells unharmed. The deployment of antibiotics over the course of the 20th century has rendered many previously dangerous diseases easily treatable. But today, more and more of our antibiotics are becoming less effective. Did something go wrong to make them stop working? The problem is not with the antibiotics, but the bacteria they were made to fight. And the reason lies in Darwin's theory of natural selection. Just like any other organisms, individual bacteria can undergo random mutations. Many of these mutations are harmful or useless, but every now and then one comes along that gives its organism an edge in survival. And for a bacterium, a mutation making it resistant to a certain antibiotic gives quite the edge. As the non-resistant bacteria are killed off, which happens especially quickly in antibiotic-rich environments like hospitals, there is more room and resources for the resistant ones to thrive, passing along only the mutated genes that help them do so. Reproduction isn't the only way to do this. Some can release their DNA upon death to be picked up by other bacteria, while others use a method called conjugation, connecting through pili to share their genes. Over time, the resistant genes proliferate, creating entire strains of resistant superbacteria. So how much time do we have before these superbugs take over? Well, in some bacteria, it's already happened. For instance, some strands of Staphylococcus aureus, which causes everything from skin infections to pneumonia and sepsis, have developed into MRSA, becoming resistant to beta-lactam antibiotics like penicillin, methicillin, and oxacillin. Thanks to a gene that replaces the protein beta-lactams normally target and bind to, MRSA can keep making its cell walls unimpeded. Other superbacteria, like Salmonella, even sometimes produce enzymes like beta-lactamase that break down antibiotic attackers before they can do any damage. And E. coli, a diverse group of bacteria that contains strains that cause diarrhea and kidney failure, can prevent the function of antibiotics like quinolones by actively booting any invaders that manage to enter the cell. But there is good news. Scientists are working to stay one step ahead of the bacteria, and although development of new antibiotics has slowed in recent years, the World Health Organization has made it a priority to develop novel treatments. Other scientists are investigating alternate solutions, such as phage therapy or using vaccines to prevent infections. Most importantly, curbing the excessive and unnecessary use of antibiotics, such as for minor infections that can resolve on their own, as well as changing medical practice to prevent hospital infections, can have a major impact by keeping more non-resistant bacteria alive as competition for resistant strains. In the war against superbacteria, de-escalation may sometimes work better than an evolutionary arms race.
Okay, so that clip does a really nice job of explaining what antibiotic resistance is. So is it a problem? The CDC says that antimicrobial resistance is one of our most serious health threats. And at least 2 million people in the U.S. Acquire a bacterial infection that's antibiotic resistant each year, and of these, about 23,000 result in death. So yes, it is a very serious issue. The estimated healthcare costs of this are $20 to $35 billion per year estimated, and the problem primarily stems from excessive use of antibiotics in humans and in animals. So here is a nice figure from the Lancet that demonstrates the contribution of antibiotic use in animals as on this antibiotic resistance problem that we're experiencing in the world today. And you can see that the contribution, so the bigger the circle, and so the bottom here is evidence that factor is contributing to antimicrobial resistance, relative contribution of factor as driver for antimicrobial resistance. And then also the size of the circle demonstrates, I believe, how much evidence is contributing to these conclusions. So you can see that our top two contributors are human antimicrobial misuse or overuse, so that means antibiotic use, and then animal antibiotic use. So these are the two huge problems. And then you can see there are many other contributors as well. So this is good to know when, in order to place kind of our topic within context. So it is an important contributor, but it's not by any means the only contributor. So antibiotic resistance is a problem for anyone who gets an infection and needs to utilize antibiotics. But many of the advances in medical treatment that we see today, think cancer therapy, treatment of chronic diseases, organ transplants, all of these really rely on the efficacy of antibiotic use and our ability, because antibiotics obviously allow us to fight infection. So if we have a surgery and we get an infection, it's not going to result in death. We can administer antibiotics and save a life, of course. So when the ability of the antibiotic is lost, the ability to safely offer people these life-saving modern medical technology advantages would be lost with that too. And this slide demonstrates some of the patient groups of which this would impact the most. However, just like all of our other topics, there is a real gap in knowledge about antibiotic resistance. We know it's a huge issue throughout the world, but there is just so many barriers to understanding how these things work. So part of it is limited resources, no systematic, we don't have really good record keeping of antibiotic resistance. We don't have systematic collection of human antibiotic use in healthcare. Programs that improve antibiotic prescribing are not widely used in the United States, so we have inappropriate use of these antibiotics. So there's a lot of issues that accompany studying these relationships. So if things seem controversial or relationships seem tenuous, this is one reason why. Okay, so antibiotics are used in animal production to enhance growth and to both prophylactically prevent infection or to treat infection. However, animals are usually given them routinely in order, because it stresses animals less. Typically, they're sick less, and this enhances growth and also prevents infection. So the CDC says that there is strong evidence that some antibiotic resistance in bacteria is caused by antibiotic use in food animals. And I believe they're mostly referring to this widespread prophylactic, just routine use of antibiotics, not really necessarily the treatment. And antibiotics may be given routinely to animals to improve growth, and it's really these long-term, low-level antibiotic exposures that are kind of the opportune environment for antibiotic resistance, whereas giving them larger treatment in times of need maybe wouldn't have as big of an impact on resistance. And then this article from The Lancet, which as we know is a very high-level journal, says that the effects of patterns of resistance from changing use of antimicrobials in animal healthcare continues to be well described. Oh, and I did want to say too, this is such good timing because The Lancet actually, that's why I had the note, did a whole series on antibiotic resistance. Some of it is about animal use, and then some of it is not, but did a whole series this month. So if you're interested, you can pursue that. Okay, and what's our evidence for this? Well, you have some in the readings that you had today on the comment from The Lancet, which was also part of that series. But basically, we see that through genetic examination that there has been evolution of bacteria from the livestock form that populates livestock to a human form of MRSA and E. coli. We also see that administration of antibiotics has been demonstrated to have an impact on antibiotic resistance of populations in that same area, and that's talked about more in the PBS Frontline story. But just like the other slide demonstrated, we do have a lot of issues that are preventing us from really understanding this relationship, and even the association itself remains controversial. Many people don't think it is a big contributing factor. Okay, so how does the administration of antibiotics impact us as humans? So this is a really nice figure from the CDC. It shows that just like in the clip, it says that the animals are administered the antibiotics. They may have one bacteria that's resistant, and since that one's resistant, they have less competition for resources and multiply. Then that resistant bacteria is on our food from the meat that we eat, or our produce because of manure that we get on the field, or from direct contact with between animals and their feces. And then we would either eat the food or come in direct contact with the animals. And it says that about 1 in 5 resistant infections are caused by germs from food and animals. And then here's another graphic that's demonstrating both parts of the serious issue of antibiotic resistance, both the animal aspect and the people aspect, where you can see this gentleman is getting an antibiotic and the same process is happening where the resistant bacteria has less competition and spreads to community members, and when he goes to the hospital, to healthcare providers, and then to community members. So should we stop using antibiotics in food, animals? The answer, I think, across the board is no. That antibiotics are extremely helpful, and it's the reason that these are so helpful is why we're trying to protect their efficacy. So antibiotics definitely do reduce animal illness and suffering. However, if we can use them judiciously instead of these the idea is if we could use them judiciously, and this is from the CDC, this could decrease the risk of antibiotic resistance in humans. So they say, because of the link between antibiotic use in food-producing animals and the occurrence of antibiotic-resistant infections in humans, CDC encourages efforts to minimize inappropriate use of antibiotics in humans and animals. And part of this strategy would be to administer antibiotics only under veterinary oversight to address health needs instead of this kind of routine use to promote growth. Oh, and I do want to say that Europe banned antibiotic use for growth purposes in 2006, I believe, because of this issue. Okay, so current issues, the dietary guidelines. So I did, I'm just going to escape. I queued this up so we could skip the advertisement. Is this the one? Okay, I think this is the one. So this is an NPR clip. Okay, this isn't working. I'm sorry. I'll just go right to the link. Sorry, you might have to listen to an advertisement. So not all of this is about meat. Some of it is about other aspects of the dietary guidelines, but...
From the latest newscast to the newest podcast, NPR One handpicks local, national, and international stories based on what you like. Download the NPR One app, a new way to experience public radio.
It's that time of year when lots of us are resolving to eat healthier. I know I am. And this morning there is new dietary guidance out from the federal government. The U.S. dietary guidelines are updated every 5 years and are considered the government's official advice on what Americans should be eating. NPR's Allison Aubrey joins us now to talk about them. Good morning.
Good morning, Renee.
So tell us, what has changed in these new guidelines? What's different than 5 years ago?
Well, a key issue is right here in front of me. It's sugar. Americans eat way too much of it.
You're holding yogurt there.
Yes, right. I've got this little tub. Right. We consider yogurt a healthy food, but I'm looking at the label here. This has nearly 20 grams of sugar, which is 5 teaspoons, about 5 teaspoons. So a key recommendation out today in these new guidelines is to eat less. Now, this may not seem new. We've already been given this advice to, cut back. but many Americans are eating, by some estimates, an average of about 22 teaspoons a day. And over the last 5 years, there's been a lot of new scientific evidence showing that this amount increases the risk not only of type 2 diabetes, but also of heart disease, even among people who are not overweight or obese.
And how much, or really how little sugar should we be eating?
Right, how little is the key. The new guideline calls for limiting sugar to no more than 10% of our daily calories. So that translates, depending on how many calories you eat a day, to about 10 to 12 teaspoons a day. So this means for many Americans, cutting sugar consumption in half. Now, I should be clear here that we're not talking about intrinsic sugars, those that are found naturally in fruits and milk and vegetables. It's all the sugar that gets added to foods.
Okay, less sugar.
That's right.
What else from these new and presumably different guidelines?
That's right. Well, one noticeable change is that these new guidelines really focus on healthy patterns of eating and emphasize getting more variety into your diet. So, for instance, instead of coming out and saying, eat less red meat, the message now in these new guidelines is to make small shifts. They use that phrase a lot, to make small shifts to alternative sources of protein, for instance, seafood, beans, nuts. Now, I have to say this is a bit controversial because last year, the advisory committee of nutrition experts that was tasked with sort of making recommendations on what to include in these guidelines, this committee came out and said Americans should be told to eat less red meat. But this is not what the guidelines say. There's no specific recommendation to cut back on red or processed meats. Now, of course, the meat industry is pleased with this. Their reaction this morning is that these new dietary guidelines are, quote, affirming that meat is part of a healthy diet. But on the other hand, I've already heard from 2 researchers this morning who are disappointed. They say the guidelines should have included specific limits on red and processed meats.
Well, how likely are Americans, do you think, to pay attention to any of this advice?
Well, you know, if past is prologue, I don't think that too many Americans are going to be paying a lot of attention. If you look, for instance, at the recommendations on fruit and vegetable consumption, which is to eat, several cups worth every day, the percentage of Americans following this advice is very low. For some age groups, for instance, teenagers, it's in the single digits. Americans also way overeat refined carbs or refined grains, but don't get enough of the whole grains. So as a culture, we have a long way to go, but I think that this doesn't mean that the dietary guidelines are not important. The guidelines help shape federal programs, such as the school lunch program and the WIC program that helps feed at-risk mothers and their children. And I should point out that these guidelines are only a small part of a much bigger public health effort to get people to eat healthier.
Okay, so just a little perspective on this. I worked for WIC when the initial document came out, for a state WIC of Michigan WIC, when the initial document came out. So for the dietary guidelines, they are released, and then there's a period of time for public comment, and then the final are released, which was this January. And what was interesting was that in the first draft, there was quite the environmental focus. And as she said, in the first draft, it really did come right. They really did come right out and say, eat less red meat. And so it was really interesting to see that when they were released, that this part of the conversation had much been deleted, and many people think it is because of a lobbyist activity. Okay, and then I just have 2 more quick recent news stories. Again, I'm sorry, you might see a advertisement here, but this one is from the Huffington Post. Both of these are from January. Okay, this one was just a regular. Okay, this one was just a regular story. Sorry. What this story is demonstrating is that because of the trends that we've seen, 2016 could be a big crackdown for this kind of routine use of. Oh, here it is. I thought it was a video. Sorry. I think you might see a advertisement first. I apologize.
Hey folks, I'm Byron with a quick kitchen tip. If you want more rise out of your bread, add a teaspoon of sugar to your yeast and water. Want to give your wallet a rise too? Get a 10% customer bonus offer with the Bank of America Cash Rewards Card. For more kitchen tips, go to bankofamerica.com/getcashback.
If you're worried about antibiotic-resistant superbugs, I've got bad news. Scientists have discovered a bacteria that's resistant to an antibiotic typically considered the last line of defense against the very worst strains of E. coli and pneumonia. Colistin is not used that often in humans because it can cause kidney damage and it's considered a last resort, but now even it may fail. It's commonly used in agriculture, especially in China, where the new resistant bug emerged at a pig farm. 1/5 of the animals were carrying it, and it was later identified in raw meat and in humans. It's spreading thanks to a gene, MCR1, that enables the antibiotic resistance to spread from one cell to another. One of the researchers told the BBC just how bad this news is. Quote, if MCR1 becomes global, which is a case of when, not if, and the gene aligns itself with other antibiotic-resistant genes, which is inevitable, then we will have very likely reached the start of the post-antibiotic era. Josh, should I be terrified?
Yeah, you really should be. Antibiotic resistance is bad. As far as colistin itself goes, as you pointed out, we don't really use it that much in human beings, but it's a major livestock drug. And we have now a bacteria that is resistant to it, and it does seem like that bacteria could mutate to spread around the world and become resistant.
Jen, so are we approaching a time when we'll have super cutting-edge medical technology to zap cancers and cure HIV, but scratching our hand on a rusty nail will be potentially life-threatening?
Yeah, I mean, it could be a possibility, right? There's a lot of mutation that'll have to happen before we get to that point. But this is something that we've kind of seen coming for a while, right? It's been decades that we've been talking about overuse of antibiotics, and especially in livestock. So the FDA says about 80% of all the antibiotics in the U.S. are used on livestock. That's something that we don't necessarily have to be doing, but we've always said it maybe is going to take some big crisis before we respond. Maybe finding this bug is the crisis that's going to get us to regulate that a little bit better.
David, I've been screaming about this for years, and it's so frustrating because obviously we're going to look back from the future and say, what the hell were these people thinking, just feeding antibiotics to pigs that aren't even sick, that don't even have an infection, and knowing that was going to increase antibiotic resistance in bugs?
Well, yeah, it's all about helping the animals grow quickly. That's why they're fed antibiotics, and absolutely, more and more. I think companies in the U.S. or agricultural companies in the U.S. are cutting back and cutting out antibiotics in feed, but not all of them, and not in China for sure.
Do you think that this is the tipping point that Jen is talking about? Are people going to start paying attention now, or will it take humans to start getting sick?
I think that I don't think we're at the tipping point yet. It's too bad. I mean, the CDC has obviously been interested in this, as have other health organizations. Patients still demand antibiotics from their doctors. Doctors tend to give antibiotics inappropriately. So it's also about the healthcare system as well as the agriculture system. And it's kind of a race to see which happens first, the big crisis or the end of this.
Joshua, what happens if we have fewer and fewer antibiotics that are actually useful? I mean, what do we replace them with? Just better hygiene all around?
I don't think anybody's 100% sure what we'll do if we don't have any of our antibiotics. That's not terribly realistic, at least not in the short term. We tend to find that a certain bacteria becomes antibiotic resistant and that knocks out one antibiotic. The idea that we would have no antibiotics anymore doesn't seem like something that's quite on the horizon. But if that were to happen, I'm not sure what we'd do.
Is there a way to develop new antibiotics that are a completely different class of the antibiotics that we understand? Should I be hopeful of that?
Not that I'm aware of. We definitely could develop more antibiotics, but that's also just kind of pushing off a problem that seems to keep on popping up again and again. And it's that even outside of antibiotics, we find drug resistance. Smart living things are able to become resistant to even really good drugs.
And then just one more. This isn't a video. This is just a story. But this is a story from NPR that is talking about how many hospitals are understanding this issue, and they're trying to ditch meat with antibiotics that they serve. And so this is, if you're interested, you can look at this clip. But I think one really important issue that they bring up in here, let me see if I can find it, is basically that many of the hospitals, okay, here we go. The biggest food service management companies have very limited supply of these items, and hospitals don't have flexibility in changing vendors or supplies, says Business. And I think a lot of times there are these food contracts that really prevent hospitals from using an individual vendor that might have access to these. But really, the biggest problem is that they're just not as available as they need to be. So that's all I have for today. I look forward to hearing from you all on the discussion board, and feel free to contact me with any questions. Bye. Have a good week.